Right, good day junior techies, and welcome to this video dealing with organic chemistry, particularly question 4 of the worksheets. What we're going to be doing is we're going to be doing question 4, and this video forms part of a series of videos that deal with particularly some theory on organic chemistry and the other questions that are in the worksheet. My name is Mr. P, and I'll be taking you through this section. So the first question we're going to be looking at as part of question 4 is question 4.2. And I thought it valuable for us to start here, as question 4.1 was simply dealing with a few definitions. So let's get some context to this question. So it's important for us to read very carefully what this question is actually asking of us. The first thing here is we see that there are some grade 10 learners that are investigating the effect of temperature on enzyme activity. They placed enzymes into 6 different test tubes, and this is the same enzyme, just in 6 different test tubes, and placed each of these test tubes in its own water bath at its own temperature. The data was recorded of the activity of these enzymes, and we can see that in the table over there. So the first part of question 4.2 is so important for us because it gives us context to this specific investigation. We can read a lot of data there, or a lot of information that helps us better understand how this investigation was conducted. So it is so important for us to read the question carefully before we carry on with answering the questions. So what we're going to see now is we're going to see that we have a table that is giving us data for each of these test tubes. Test tubes on the left of my table, I have got temperature going up in increments of 10 degrees Celsius, and an activity score that was given for each of these test tubes. Now you'll notice that there is no unit for this activity score. So we refer to these values as arbitrary, which means they are there for us to use in comparison. So I'm able to compare test tubes 1, 2, 3, 4, 5, and 6 with each other in the context of the activity score of the enzyme, simply because there is a value there even though the units are arbitrary. I would expect that the units would be the same for each one. So I can compare them. So the next thing for us to do is answer the question. So here we have to draw a line graph using enzyme activity and the temperature that the enzyme activity was measured at each. So I'm going to bring across my data table over here, and we're going to analyze this very quickly. The first thing I have is temperature, and this is going to be my independent variable. I have my dependent variable, which is what I'm measuring, and that is the activity score for the enzyme at that specific temperature. My independent variable is going to be plotted on my x-axis and my dependent on the y-axis. So I'm very sure that you've already drawn these or this graph, and we end up with a graph that looks something like this. Okay, so this graph represents the change in the activity level or the activity score of a specific enzyme as the temperature changes. We can see the temperature moves from 10 degrees all the way to 60 degrees, and the line is going to represent how active my enzyme is at each of those given temperatures. We can see as we move towards 40 degrees from left to right, my activity increases substantially. After 40 degrees, the line drops, which means my enzyme activity or my activity score is going to drop after 40 degrees Celsius. That's just looking very briefly at what the graph is telling me. Now, in order to mark this graph, because we get marks for these graphs, usually about 6 marks, we use the acronym TCLSP. Now, the letter T stands for type of graph. Because we were asked to draw a line graph, have we actually drawn a line graph? It doesn't really matter what your graph looks like. If it is a line graph, you'll get the T mark. Now we have C. This is the heading or the caption. And my caption has to have both of my variables in it, particularly different temperatures and activity score. And I can see that at the top over here. There I've got next L. What the L stands for are the labels. Activity score on my y-axis and temperature with unit degrees Celsius on the x-axis. If those are present, I'll get my L mark. S would be for scale. So here we're looking at the relative distances and the number of units that each of these scale lines represent on my graph. From 10 to 20, I have 10 scale units. From 20 to 30, 10, 30 to 40, I've got 10 units as well. And if my scale is correct in this context, I will get my scale mark as well. Now, it's not only for the x-axis, it is for the y-axis as well. So I need to make sure that those are there too. Once I have my scale mark, we look at plotting. Now we check, as the examiner or the marker, we check the points that you've plotted and whether those points actually reflect the points that we needed to plot based on the table of the results that we were given. If that's the case, for plotting we get 2 marks. If I plot 1 point correctly, I'll get 1 mark. If I plot all of my points correctly, I get 2. But if for some reason one of my points was not plotted correctly, I will only receive 1 of the 2 marks. For a total, this graph is out of 6, so there's a total of 6, and now you know where those marks come from. The last 2 questions, and you'll see I've pulled the graph across here, the last 2 questions that we're going to be looking at is 4.2.1, explain why the activity score of test tube 1 is only at a value of 2. So this is basically looking at our understanding of how temperature affects enzyme action. So the first point for test tube, for the first test tube here at value 2 is because temperature is extremely low at 10 degrees Celsius. Because the temperature is low, the enzyme has less energy and therefore will be moving less in that test tube. If it were acting on a specific substrate, it would make less contact with that substrate and be less effective at a very low temperature. That is the answer for the first question, 4.2.1. If we look at 4.2.2, it asks us pretty much the same question, except now we are looking at test tube 6. So now we're no longer at a low temperature, we're at a high temperature. So this question tests our understanding of how high temperatures impact on the activities of enzymes. So now let's quickly look at how we would structure our answer here. So enzymes, we should know, are quite sensitive to temperature. 1, low temperatures, and 2, in the case of this question, high temperatures. So now we're referring to high temperatures. And if we look at high temperatures, how do high temperatures impact on the structure of an enzyme? The enzyme at high temperatures would change its shape. Or what we could refer to is denature. An enzyme or a protein would denature at a very high temperature. But what does this actually mean? It means that my enzyme or my hormone would no longer function at a high temperature because it's either broken apart completely or it has changed its shape to such an extent that it can no longer bind to its substrate. Now you can think to yourself now very quickly, what does this mean for the functioning enzyme? It's not able to do the job that it is supposed to do. So when an enzyme denatures, it becomes less effective. And we can see this. After 40 degrees in my graph, I can see the effectiveness of my enzyme decreasing substantially. But what do I need to make sure of in my answer? The fact that high temperatures cause enzymes to denature and they can no longer bind with their substrate and therefore become less effective. Okay, right, so I hope that this video has helped with your understanding of organic molecules and the action of organic molecules, particularly that of enzymes. Please tune in to some of our other videos to get a better understanding of organic chemistry at grade 10 level. I'm looking forward to seeing you again. Have a great day. Bye-bye.